Hey guys, what's up? Today I'm going to be doing a review of Chapter 6 in Geometry. For those of you guys who just want a refresher, I'm going to be going over the concepts that I think are important and that I would be sure to know for the upcoming test. So the first is how to find the sum of the interior angle measures of a convex polygon. Now remember that a convex polygon is a polygon in which the diagonals all are contained on the interior of a figure. So I'll give you an example. This is a convex polygon because you can see the two diagonals that exist in this figure exist in the interior. If you have a polygon, let's say like this, you have one diagonal here, but then for this diagonal, it exists outside of the figure. So that's going to be a concave figure. So what we're dealing with this equation coming up is going to be convex polygons. And remember, a polygon is pretty much just that. So let's go ahead and take a look. We know that the sum of the interior angle measures are equal to n minus 2, where n is the number of sides, times 180 degrees. We also know that the sum of the exterior angle measures is always going to be 360 degrees in a polygon such as that. I'll actually look it up. A convex polygon. So convex polygons, the sum of the interior angle measures is n minus 2 times 180. And the sum of the exterior angle measures is 360 degrees. Now I can actually show you why this equation works based off of this. So if we know that the exterior angle measures all add up to 360 degrees, if you take the number of sides, so let's take a triangle, you have 3 lines in a triangle, and we know that a flat line like this has 180 degrees. So you have 180, 180, 180. But we also know that this is going to separate out into 3 different exterior angles, which are going to add up to 360. So you can't just take the number of sides and multiply it by 180, because that wouldn't work. That would give you as if this was a total flat figure. So you have to subtract these 360 degrees from that. And that's because if you take the 180 n minus 2 and you distribute, you get 180 n minus 360. So that's a little proof thing for you guys. Now if you move on, you're going to want to note that in a parallelogram, so normally they're going to be drawn like that, and basically that's saying that in a parallelogram you have a pair of parallel sides like this, and it's actually 2 pairs of parallel sides if I'm not mistaken. And in a parallelogram like that, what you're going to have is opposite sides are congruent. And this is for several reasons, but basically the important thing to know is if you choose any side, let's say this one, it's going to be congruent to its opposite side, which would be this. This is going to be congruent to that in turn. In addition, you're also going to want to know that the opposite angles in a parallelogram are congruent as well. So if you have this angle here, this is going to be congruent to this angle, and this angle is going to be congruent to that angle. And according to the hinge theorem, it's because each angle is going to correspond to a certain length, and if you have the same length, you're going to have the same angle. But you don't need to worry about that. You also need to know that complementary angles, or consecutive angles. So this angle is consecutive to this one, this angle is consecutive to this one. So like this, consecutive angles are going to add up to equal 180 degrees as their sum. It also works that yes, that's basically it. You're also going to want to know that they bisect each other, the diagonals that is. So if you have a parallelogram like this, these two diagonals are going to bisect each other. And what that means is that when you cut this in half, you're going to have this piece congruent to this piece, and this piece congruent to that piece. Now, that's all the assumptions you can really make off that one. So if we keep on moving through the chapter to take a look at what is important, you have properties of rectangles, which they're important. You need to know that in a rectangle, the diagonals are going to be congruent, so the entire pieces are congruent to each other. You also need to know that in a rhombus, all of the sides are congruent, right? So if this is a rhombus, all of the sides are going to be congruent to each other, and the diagonals aren't necessarily congruent, but they're perpendicular. So what that means is that the diagonals in a rhombus are going to all produce 90-degree angles, and that is used a lot, because what's going to end up happening is they're going to give you, let's say, this angle, right? And let's say this angle is 30 degrees. And they're going to ask you what the measure of this angle here is. And what you're going to end up having to do is add this 90 degrees to this 30 degrees to get 120, and then you would subtract 180 by 120 because you know what the sum of all the angle measures in a triangle is, and you're going to get 60 degrees for this remaining side. It goes in the chapter, it talks about which angles are congruent to which angles in a rhombus with the diagonals. Basically, it's going to be a little bit difficult for me to show this. You have this angle congruent to this angle congruent to that angle, this angle congruent to this angle, this angle congruent to this angle. And basically what that tells you is the diagonals in a rhombus are angle bisectors. In terms of the vertices that they connect. So if you keep moving through, you have just a few more things. You know what a kite is, and in a kite what you know is this, let's just draw it like that, is this angle here. So let's say angle 1 is congruent to angle 2. In addition, you know that the diagonals are perpendicular. So you know that this is 90 degrees, that's 90 degrees, this is 90 degrees, and that's 90 degrees. You also are told several things about trapezoids. What you're told is that in a trapezoid, the base angles, right? So you're going to have in a trapezoid at least one pair of parallel sides, exactly one pair of parallel sides. And in an isosceles trapezoid, the base angles are going to be congruent to the other consecutive base angle. So you know that this angle here is congruent to this angle here is congruent to this angle here. And you know that these are supplementary, which mean they add up to equal 180 degrees, and these are supplementary. In addition, you know that the diagonals are congruent, right? So we know that the diagonals are congruent in a trapezoid, an isosceles trapezoid. And we also know, I'm going to go over a few equations with you here. We know that if you have an isosceles trapezoid, or really any trapezoid for that matter, and you have the two parallel lines, and then you have a line going from the midpoint of, let's say, AB to the midpoint of, let's say, CD. You know that the measure of this, so let's call this x and y. You know that the measure of xy is equal to 1/2 times AC plus BD. And that is because what you're really doing is you're averaging the lengths of these two, since x is halfway between the x and y of AB, and y is halfway between the segment CD. So you're really just averaging those. What you will be asked to do is you're going to be given this mid segment, and you're going to be given a base, and you're asked to find the remainder of the other one. And that's not a big deal. You just solve it algebraically for xy, and you can figure that out. So that's pretty much summing up what we did in this lesson. If you have any questions, feel free to let me know. I'm a bit sick, so I'm sorry if I wasn't as energetic in this video. So thanks for watching, and hope this helped.